All right, guys, so here we are back, and we're going to take a look at our equations in polar form. So I mentioned the first one we're going to take a look at is our very loved favorite, the unit circle. The unit circle in rectangular coordinates has the equation x squared plus y squared equals 1. Our x squared and y squared equals our r squared form that we've studied before. However, when you're in polar form, it actually turns out our unit circle has a much simpler equation. The unit circle is simply the object whose radius is always 1. When you're describing that in the polar system, that's it, right? So think about polar equation versus our rectangular equation. These are equivalent, right? But r equals 1 is quicker to graph if you're graphing in polar form. So, well, it's a bad tracing, but there you go, the unit circle. So if we think about circles, r equals 5, a bigger circle, r equals 10. It's kind of intuitive in the polar system. The polar system also helps us create the equations of lines really easily. If we think about something like a line, you can represent a line by giving an angle. Think about this last example where I kind of highlighted the angle. The angle pi over 4 is saying your angle is pi over 4 everywhere, right here, but then this part is for pi over 4 with a positive radius. You can also think about this pi over 4 with a negative radius, kind of going back this way. So this whole thing is actually pi over 4, positive radius, negative radius. Then another way I like to describe what we were doing before is sometimes it's easier in polar form, with this one we're looking at, to start with your angle. Like you're on the pi over 3 angle line, and then your -5 radius, meaning you're going backwards and you're going down rather than going up and out. So a couple ways to think about that. So circles are easy, lines are easy, but we're also going to see things that like curves and loops, kind of like with the parametric equations, that polar equations get fun. They give us cool graphs that are simple in polar form and really complex in the rectangular system. So let's just pop over to Desmos. I'm going to stop my share and just open up a blank Desmos page. So you can just put question mark. All right, guys, so let me get this to share. Still getting my Zoom proficiency up. Okay, so you guys should be able to see right now. I'm just on our Blackboard page. Go to a blank Desmos page, not our Desmos activity right now. We'll pop back in there in a second. And let's just type, make sure you're switched over to polar coordinates. And right now I'm still in radian form, which is fine. So if I do something like r equals 1, Desmos knows what to do. Notice my grid points are a little pulled out here, and my radius points are a little pulled out. And let's say we do something like zooming and not meaning to zoom. There we go. Theta, kind of like pi. Theta is your angle. So if you just type, I'm going to do that again, guys. Theta. Theta. Okay, so, oh, my internet connection is unstable. I may have to, it may make me fuzzy. Go ahead and do theta equals pi over 4. Why are you unhappy? Sorry, you can't graph theta as a function of anything yet. Why not? Ooh, look, y'all, how cool. It made it a slider. I'm going to have to play around with Desmos, why it doesn't like that, right? Because I found out that Desmos doesn't always graph things quite like I think they should. I think they should be graphed. And I want to show you kind of what it was doing while I was scratching my head earlier. If I were to think about the point, I'm going to take this back to a radius, take it back to a radius of 1. Don't do that. r equals 1. Okay, so there's my radius circle. And then if I think about this pi over 4, when I describe it on paper, I know what I'm trying to do, and that's what it does in polar form, but Desmos is having an issue. I'll troubleshoot that in a second. Figure out why it's not cooperating. But when I was trying to tell Desmos, okay, give me a radius 1, and I want you to be on the pi over 4 angle, it wasn't quite doing what I expected. Now, notice it's kind of close, but if you look at my radius 1, it's not on radius 1, it's not quite on the pi over 4. What it's actually doing is it's taking this pi over 4, approximately 0.7, and it's still thinking about our point like this as a rectangular grid. Okay, so Desmos doesn't understand this idea that I want it to be polar. All it knows is to plot the point. It's kind of like it's plotting the point in the rectangular system and overlaying our polar grid, which I find a little strange. You have to do a little bit of behind the scenes coding to make that work. So this is a case where I think that visualizing, in this case, a polar point, Desmos isn't going to be able to check that necessarily for you unless you are putting the 1 cosine pi over 4, 1 sine pi over 4 back in, which is kind of defeating the point of doing a polar coordinate, if that makes sense. And also, it's not doing our angles really quickly and easily. So what I want to do is take us back to the match my polar points Desmos activity. If you want to switch back over there, those looked really good, guys. I'm going to stop our pause, and I'm just going to kind of preview a few things that you're going to do in here. So I'm going to switch it over to student view. So pictures in white. And I'm just going to put it student view form. So you're matching the polar points. We're just going to walk you through some of the things you're doing here. Okay, so here you're looking at polar points and predicting. Okay, you're going to do a little bit with negative angles. The activity talks about this idea of having different ways to represent the same point because we have coterminal angles that put us different places. I don't know, you can hear some background noise there. And then, let's see, these type things. So fill in your table, and then you guys are going to do some matching. Okay, so one of the things that I want to point out in this matching is the idea of converting between polar points and here Cartesian, which is another name for rectangular. So when you see this P equals, this is polar form. You've got a radius and you've got an angle. Then in Cartesian form, you're trying to find what that looks like. So I just want to do a couple of these for us and talk through a few of them and then kind of go on. So for example, let me try to move these out of the way so I can get my cards out. In some of these card sorts, they're not all guaranteed to have a match, like you might have some extra cards and they don't always tell you that. But let's take a look at matching up some of our points with our grids. So let's start with maybe this guy, 2 and pi over 6. So radius of 2 and then angle pi over 6. So that should put us in the first quadrant. So this guy's out, this guy's a possibility, this guy's out, this guy's out, right? So then notice this gets matched up. Those ones. And then when you're thinking about your Cartesian coordinates, notice you really only have 2, right? Which is kind of like, whoa, what in the world is going on? And they don't look like an XY that's been simplified. So sometimes we can simplify, that's great. But sometimes in these, they're not having you do that simplification. So if you take a look at this one, it's trying to emphasize that if you know the radius and you know the angle, then the x coordinate is going to be the radius times the cosine of that angle and the radius times the sine of that angle. But if I wanted to tell someone where to go in rectangular form, I would not necessarily do it like this. So think about your cosine of sorry guys, I was looking at the wrong, pointing to the wrong thing. You would not necessarily tell someone, and I just realized there's a 5 there. I don't want that 5 there. You would not necessarily do 5 pi over 6, or in this case, cosine of pi over 6, right? You would tell them like the decimal form. You could substitute. I wish they had the ones that matched here. Let's see if they have them below. Oh, they do. They're being blocked by my face. Trying to get these out of the way. Oh, we have them. Okay. Maybe we have them. Okay. So let's see. Did I miss any other ones here? No. So in this particular case, it doesn't look like I have one that has my radius of 2. All of them have a radius of 2, but specifically cosine and sine with pi over 6. Okay, so I want us to think for just a second about that pi over 6. If you don't see one that matches the specific angle you're looking for, you could also think, and I think this is maybe a tad bit tricky, that we could rephrase it in terms of angles that are coterminal. Okay, so in this case, let me take you to another example. This may be a little bit simpler in this one. So let's say we start with the polar form, radius of 2, angle 5 pi over 6. So in our 5 pi over 6, that's going to be close to pi, close to 180 degrees. And it looks like, ooh, this one matches. Pull this guy down here. Sometimes I wish we could make our screens or our cars a little smaller. So that looks good, right? Your radius 2, and then your angle is 5 pi over 6. And notice for this one, if you think about the coordinates of this, the x coordinate would be 2 cosine 5 pi over 6, 2 sine 5 pi over 6. So in this case, notice these Cartesian coordinates line up nicely. Now, again, if you were to actually say, hey, what is 2 cosine 5 pi over 6, 2 sine 5 pi over 6? We could do that if we looked at our unit circle. We could also, I'm just going to ask Desmos to remind me of that. 2 sine 5 pi over 6. So in other words, it's telling us our x is negative 1.7 approximately, and y is 1 in our Cartesian plane. So take a look at this one. Negative 1.7, that feels right. Getting a zoom on my face, I'm sorry, you guys. And then we're up 1. I'm not a YouTuber, that is clear. So this gives us what we want, but it's not simplifying those coordinates. Whereas in some of your homework, you're going to be cleaning those up and simplifying and not leaving the cosine and sine in there. So hopefully that makes sense. Now let's return to this other example, because this Cartesian one is a little bit tricky. If you think about, we're not seeing that pi over 6, I already mentioned. Let's go and pull our other Cartesians over here. Then see if we can find an angle that gives us the same idea. So if we think about 11 pi over 6, 11 pi over 6 is almost 12 pi over 6. That's almost back to where we started. So that's not it, right? I'm going to bye-bye to that one, right? And then let's kind of process of elimination. If I think about, let's see, these two angles, and this guy, negative 7 pi over 6. So if I think about negative 7 pi over 6 and think about where that angle is, think about it maybe even on your polar grid. Oops, sorry guys, I didn't mean to pop over there. Think about that on your polar grid over here. You don't really have these negative angles over there for you. So that's another challenge here, right? And it's not going to let you do this. Right, so let's think about negative 7 pi over 6. Think about that's going to start, and then negative 7 pi over 6 is going to be over here. Now, in terms of that guy, right? That guy actually feels kind of similar to what we just did. So I'm gonna have to take a look at our coding, make sure everything's right in our Desmos activity. I may have to get back to you a little bit on this one, but right now I'm not seeing a match for this guy, whereas I'm seeing a match for this one. And then when I'm looking at this one, it's kind of interesting that the -7 pi over 6 feels like it should match with this guy, right? Because you're taking a look at that -7 pi over 6 angle is putting this in the same place. So I'll have to make sure that we didn't have any typos in this coding, but right now I would match that one with this one and not match it with that. So these card sorts are difficult. I'll take a look at it and give you guys some hints in a couple minutes, but I want to open it for questions right now, and then we'll talk about some other interesting polar graphs that you could see. Okay, so questions, you guys can unmute yourself or type into the chat box. So what I'm going to do is I'm going to pop over to WebAssign and another Desmos in a second. I'm going to stop my share, give you a couple minutes to take a look at continuing the Desmos activity and seeing what questions you have before we go on. And then again, we're going to look at some complicated or more complicated graphs that are not radius equals and angle equals. Okay, so I've stopped the share. Keep going, and I'll let you guys know when we're going to restart. I'm not going to turn Zoom off, so stay on Zoom. If you have a question while we're waiting right now, you just unmute yourself. If you're watching this later at home, you can kind of use this time to work on your Desmos, hopefully, as if we were in class. Okay, so it looks like lots of you are kind of progressing through that Desmos activity. Any questions that we want to go on and take a look at now? So what I want to do is go ahead, I'm going to share my screen. Yeah. Sorry, guys. Just saw my little one pop in if you're watching this later. Hey, go sit down, finish your report. Y'all, I don't have the editing skills to edit this out if you're watching this later. So So I'm going to go ahead and get into our WebAssign and get that ready for a second. And then we will take a look at a few more Desmos things. Yes. Okay. I'm going to turn one of your assignments on here, guys. It's just not displaying yet. All right, so, oh, I think it's maybe not sharing that WebAssign part. So in your WebAssign, I'm going to end that share and then try to see if I can get, there we go, the actual WebAssign. There we go, to share for you guys. So on these ones, a lot of the beginning of the WebAssign is kind of what we're looking at with converting between polar and rectangular. So very, very similar. Keep in mind, again, on some of these, you can't use Desmos, but because of the way that it's asking you to think about it, but then others you can. Now, where we're really going to think about getting past the points, the fun part, is some of these types. So some of these, for example, like r equals -6 cosine theta. Right now, we might not know what that looks like. In other words, it's not just an r equals -6 or an r equals 6. It's a more complicated type of graph. Now, there's a lot of things that polar graphs can do that are really cool and really fun. So I wanted to see how many of those were in your WebAssign, but what's in there, most of it you should be able to do right now. There's a few cool things. I have one more Desmos activity that you guys will be doing in this section. So I'm going to share that screen. Take us back there. There we go. And I just want to go back to a blank Desmos page. Let's get rid of the stuff. So remember, if I just type r equals, then it will do my circle, but also make it like a slider. But let's do the r equals 6 cosine of theta. Okay, so this is pretty cool. And what it's doing here is something we might not expect. And I just want to contrast. Again, we're not going to do like super deep dive into polar because we don't have tons of time. But what happens here is, notice this graph has a circle where the end is at 6. And the circle is kind of positioned on the x-axis. Contrast this with 6 sine of theta. Notice how now we have a diameter of 6. We end at 6 on the y-axis. Hold on just a second. You can go ahead and go upstairs and do your Pokemon reading.
Yes, Mommy.
Okay, go ahead and go up there.
Bye,
okay, we're done. Okay, there we go. All right, so for these ones, cool stuff happens. I'm going to turn this one off for a second. And one of the things that you're going to play with in this next Desmos activity, I'll show you the code in a second, is not only the r equals 4, r equals 6, r equals cosine 6, but notice if I start changing the angular speed, like 6 cosine of 2 theta, this is a much different graph, right? We get something that maybe is hard for us to analyze. We don't necessarily have all of the skills. Got 6 petals there, 7 petals, but you've got some cool stuff. Same thing like when you start doing things like cosine squared, right? And sine squared of things. Different cool things are going to happen, right? That is part of our exploration. So let me show you that. I don't want you to get too worried about analyzing like, why does it look like this? I want to make sure you understand the basic theta equals the line, and then you think about analyzing the r equals. And I do want you to be familiar with, just for later reference, 6 cosine theta, 6 sine theta. Both of those, when they just involve cosine or sine and a speed of 1, gives us a circle. Otherwise, they do something different. if we have a little bit of extra time, which I don't know that we will this semester, we might come back and do some more fun stuff in Polar. So right now, you guys are all in the Match My Polar. There's one other Desmos activity. I'll go ahead and have you log into it just to make sure you see it. And then I think that'll kind of wrap us up for today. So the other activity focuses on your graphing. So let's see. This is Match My Polar, or Introduction to Polar Graphing instead of Match My Points. So this one is K5629F. So if you would just kind of switch over, you can just open a new window, a new browser tab, and open that up. Should be able to keep your other one. And this particular one is going to go through those. At the very, very end, I don't think anyone's in right now, but in the very end, you guys have move those pictures again. In student view, you're going to play around with matching these up with that cosine and sine, and then changing those radius values that I just gave you. So think about these ones are all going to be cosine. These ones are all going to be sine. And then you guys are going to play around a little bit with some of the other things that are a little bit trickier, kind of exploration parts here. It explains a little bit about some shifts. Okay. And then you're going to do some matching. And then, it's going to boot us soon. It's going to talk about that case where instead of radius equals cosine theta, we look at radius equals 2. You have a slider that allows you to kind of change those petals. Right, that's the 2. These are 0.5s here. And kind of investigate what's going on. Okay, now it's kind of cool that they overlay the trig function that we're looking like and or using in rectangular formula on top of this. Again, I don't want you to stress too much about getting it right in terms of trying to connect all the dots on why the graphs look like this. Just kind of have fun with these polar graphs and use Desmos to match them up. Now on these ones, what you're doing on slide 19 for this card sort is using slide 18. It's all radius 1, but you're matching up the B values from the other page. So use slide 18 to do that card sort. All right, guys, so there's a couple ones after this where you're going to be looking at the secant and also the cosine and kind of some relationships between those. You're also going to get a chance to make your own polar work of art, playing around with these, and then just reflect on the polar graphs. All right, guys, so I'm going to open it up to questions. Let's see, we have one person in here for our activity, but you should definitely finish the Match My Polar Points first, and then Introduction to Polar Graphing. Some of the things that are in this Introduction to Polar Graphing are harder than you're going to see on those web assigns. So again, don't stress too much about those complicated graphs. All right, so questions here. All right, so I want to take the last couple of minutes to just talk about our schedule and what is going on in terms of testing, how all of that will happen, and what to expect. I'll try to put this later this week in summary form as well, because today is our last Zoom meeting for the week, and I won't see you guys on Zoom again until Monday, but I will have Zoom online office hours. So it was trying to get us to Blackboard page here. So we can get us back. So on our Blackboard page, I tried to do a little bit of modifying for test 3. And so what I put on here was it opens 4/7. So if you're looking at your calendar, go ahead and pull up a calendar. So I'm not telling you that guys the wrong days by accident. And let's see. So next Tuesday, which is the 7th, not a day we have class, and I'll explain why, your test will open. What we're going to use next Monday for, which is the 6th, is a review day. So normally if we were in person, we would have like, okay, we finished it up. Any loose ends, like anything we didn't quite get, you would work on in that class. We really don't have any loose ends as far as what you're going to be accountable for. Use your Desmos activities as those explorations, and then really kind of use those WebAssigns to solidify the types of questions I expect you to be able to answer. Now, keep in mind, a few things are going to be different about this part because we're online right now, but your Unit 3 test will be online. It will open on 4/7, the Tuesday after our review session on Monday. So I'm still kind of thinking about how I want to work our review session on Monday. The best way to do that, sometimes I give you guys a Kahoot ahead of time or a Kahoot that day. So I'm still thinking on how I want to manage that. But we will be doing review stuff on Monday. And what I would like to do is open up that test Tuesday morning or at the beginning of the day, Tuesday, like 12 a.m. or whatever, so that you have it the next day. I may even open it up later on Monday for those of you who are ready to take it. And then my plan is to leave it open through, right now I'm thinking like Saturday evening, to give you guys a window of time. Because what we normally do is review on Monday, test on Wednesday. But instead of your test being due on Wednesday the 8th, I know some of you guys during the week is not the greatest internet time. Like if you've got parents or siblings working at home during the week, your weekend might be better. So I want to make sure I give you guys a long enough window of time to actually do the test. So what I'll do is have it open on Tuesday at the latest, maybe Monday, and then probably close Saturday end of the day. You guys let me know if Sunday's a better day for some of you. We'll just see. But tentatively, Saturday night to close. And then what will happen is I'll put a time limit on it. So when you click on the test, you'll have, I'm thinking, a 2-hour window, kind of like we were in class. You have a 2-hour window to actually do the test. Then once you submit it, you're done with the test and you'll be able to review it after everybody finishes, just to kind of make it fair. So it'll show you your answers after I make it close, which is another reason to maybe have it close Saturday so you can review it on Sunday. I think we'll do that. Review it on Sunday after it closes. And then we can take any questions if we need to the next Monday, but then also go on to our next unit. Now, again, a few reminders for this test. I mentioned at the very beginning that I want you to start organizing any formulas you need on a note card that you can use on the test. You can use anything you put on that note card. You should have plenty of space to write some stuff, but I don't want it to be quote unquote open notes. I want it to be open note card because I really want you to think about the things you need and having them all in one place, because I don't want you to run out of time. That's kind of my biggest concern for open note tests. I don't love them. I also tend to make them harder. So note card, which means focus, and then 2 hours once that test opens. Hopefully it makes sense. You guys can leave me any comments in that chat box if you need to. If that's not making sense and I can clarify. But you will also be able to use Desmos for the whole thing. But you also want to make sure that you're kind of working through your WebAssign with Desmos, because as I've just illustrated with some of the polar and Cartesian coordinate stuff, it's not as easy in terms of sometimes Desmos isn't doing what we think it should do with those polar graphs. All right, guys, so I will remind you of all of that via email when I send out these videos. Any questions from me right now? I'm going to stop this share. Okay, so what I'm going to do is we'll go ahead and end the session in a second. If you have any questions, you can just email those to me and I'll get back to you. I am going to be on Zoom tomorrow. My office hours are from 11 to 12. I don't have any office hours on Friday, but if you have some specific questions as you're working for these, you can just pop on or send me an email, request a Zoom meeting, and I can set up individual meetings. So let's see. I will follow up with you guys about that card sort, or it looked like we didn't quite have anything matching up. Get back to you on that. I'll just make sure all of our programming is in order. But other than that, look for the follow-up email. I'll get these videos posted in case you need to see anything again. And then I'll let you guys know probably on Friday what I plan to do in terms of the format of our review Monday as I kind of decide what I think is going to work best. All right, guys, thank you for participating, and let me know as you have questions.